Advantage of the dimensions or dimension analysis. Advantage of dimension analysis. The first one, checking of correctness of the given equation of a physical equation, number one. So, in order to check the correctness of an equation, we have to show that both sides of the equation have same dimension. In order to check the correctness of an equation, we have to show that both sides of equation have same dimension. In order to check the correctness of an equation, we have to prove that both sides of equation have same dimension. So this is called principle of homogeneity also. This is called principle of homogeneity also. So according to this principle, we discuss an example. Vf is equal to Vi plus At. This is the first equation of motion of the physics, and we have to prove or verify that this equation is dimensionally correct. So we discuss first of all dimension of Vf. This is velocity. Velocity is always equal to displacement over time. So having dimension t minus 1, and same is the dimension of Vi. Dimension of acceleration is rate of change of velocity. So change in velocity divided by time. So the dimension of acceleration is this, and dimension of time is t. So we put these values in this equation. So we can write L t minus 1 is equal to L t minus 1 dimension of Vi plus L t minus 2 into t. This is Lt1 plus Lt minus 2 plus 1. This is equal to Lt minus 1 plus Lt minus 1. This is 2 Lt minus 1. In this equation, this is the number 2, where number 2 on right side is dimension less constant, so cancelled for dimension analysis. So we get the result. Left hand side is equal to dimension on the right hand side. We can write also m L t minus 1 is equal to m power 0 L t minus 1. So this equation Vf is equal to Vi plus At is dimensionally correct and is also physically correct. So this is one of the advantage of dimension analysis. Now we discuss another advantage, and the second advantage, derivation of the formula. To derive the formula, so dimension analysis is used to derive a formula, but the success of this method depends upon the correct guessing of various factors on which the physical quantity depends, Example, we have to derive the formula for the wavelength of matter waves. Wavelength associated with any moving particles called matter waves. So this is de Broglie concept, and we know that any particle have mass as well as velocity, and Planck's is also used, his constant, and we can guess that this wavelength, so we write that lambda is directly proportional to h की power a, m की power b, and v power c, where we can write this equation as constant h a m b v c. Now we determine dimension of each parameter. Lambda, wavelength having units meter, so the dimension of wavelength is, this is dimension of the wavelength, dimension of h, Planck's constant. We know that E is equal to hf, formula for the energy of the photon, and h is equal to energy over frequency. E is energy, f is frequency. Unit of energy joules, which is equal to Newton into meter. Newton is again equal to kilogram meter per second square into meter. So this is kilogram meter square second minus 2. So dimension of E is m L square T minus 2. This is the dimension of energy divided by frequency. Frequency has the unit of hertz, and that is reciprocal of time period. So this is T inverse dimension of the frequency. This is T inverse, and we can write m L T minus 2 plus 1, and then this is equal to m L T minus 1. This is the dimension of h, Planck's constant. So, and dimension of other parameter mass is simple. So this equation number 1 can be written as in terms of dimension. Equation 1 can be written as m0 L T0. This is the dimension of wavelength lambda. Then constant or dimension of H is m L square T minus 1, dimension of mass having power A. M is the dimension and power is B, and the V is the velocity having units meters per second. Our dimension of velocity, this is dimension of velocity having power C. So further we can write m0 L t0 is equal to constant ma L2a t minus a mb L is c t is minus. Further we can write constant powers of masses, m is a plus b, power of length 2a plus c, and t minus a minus c. So now comparing the power, m is equal to m a plus b, so a plus b is equal to 0. Then for length has the power 1. At the right hand side, length is 2a plus c, so we get 2a plus c is equal to 1, and the third t0 is equal to t power a minus c, यहाँ से minus a minus c is equal to 0. So these three equations, we solve them with each other and we can calculate the values of a, b and c. Since there are three equations, a minus b is equal to 0, 2a minus c is equal to 0, and minus a minus c is equal to 0. So from this third equation, minus c is equal to a. So above equation, 2a minus c is equal to 0, 2a minus a is equal to 0, then a is equal to 0. This is not 0, this is equal to 1, sorry, this is 1, 2a minus, this is 1, 2a minus c is equal to 1, here is 1, and we conclude 2a minus a, then a is equal to 1. Value of 1 of the power of h has a 1 power, a is the power of h, and that numerically that's equal to 1. Now a minus b is equal to 0, then b is equal to, then a is equal to b. Since a minus b is equal to 0, so a is equal to b is equal to 1, minus a minus c is equal to 0, so minus 1 minus c is equal to 0, c is equal to minus 1, ये भी ठीक हो गया, और b की पावर 0 जो है, this is a plus b is equal to 0, so क्या करते हैं, a plus b is equal to 0. Again a plus b is equal to 0, then b is equal to minus a is equal to minus 1, b is equal to minus 1. So these are the values of the power, and we can put these values in the above equation and we get the result. So putting the values, of power in equation 1, we can write lambda is equal to constant h power a having numerical value 1 and m has power b minus 1 and v has power c which is again minus 1. So this is equal to constant into h over m v. Numerical value of this constant is 1 and this is the formula for wavelength of the matter waves given by de Broglie. So lambda is equal to h over momentum, hence proved, hence derived.